Hello everyone, in this video we are going to see segment trees. Segment trees. Okay, what is segment tree? Is basically a tree which stores the information of a range. Okay, which what? It stores the information. It stores the information of range. For example, if you see, I want, um okay, give me, the maximum value in interval of 2 to 6 from the given array. This is an example. So what if my question is, if someone asks me, give me the maximum value from this interval 2 to 6, then of course if someone asks me and I have an array, okay, an index from 2 to 6, I can just go and find it out. But if some multiple times you are going to get, every time you are not going to calculate it. Instead of that, you can store this information, that is maximum value or minimum value or the sum, in the array, and then just based on this you can search in the array, I mean in the tree, and tree will be stored as an array, the value of tree. Okay, now this is what segment trees. Let's see an example. How is the structure? Is, let's say we have an array of size 0 to n minus 1. Okay, we have this array. Now I want to, I will be storing the sum. Okay, the sum of ranges in this segment tree, and later if I'm going, if I have query, then I will go and search in the tree. Okay, now first there are two things, is build. In segment tree implementation, we have build and we have query. Now let's see first the build. Build means how we are going to build this segment trees. Okay, let's see, let's take an example as, 1 2 3 4 5 6. Simple example we'll take. And now before assigning the values, let's construct a tree. Okay, basic segment tree is a binary tree, consider. Now first we will write a range. Range will be, see, segment tree follows the divide and conquer rule. Divide and conquer rule. Okay, and it is a basically binary tree. Binary tree. And the representation in array, it might be 2D array, it might be 1D array, based on the requirement. Now let's first find the range. What we are talking about range, right? Everywhere. Now my root node. Range will be what? Indexes from 0 to 5. Okay. Now first is, see, in this divide and conquer means this one and this one. We will split this into half. Then what we will get is range. What range I'll get here? 0 plus 5 is 5. 5 divided by 2 is 2. Okay, that means 0 to 2 here, and my range here, it will be 3 to 5. Okay, these are the indexes. Now next is, as we are finding first the range, then we will find the index, and I'll find the index, and then we will assign the values. Okay, now if I go further, okay, let me enter this. Yes. Now what is the range? Here it will be 0 plus 2 is 2. 2 divided by 2 is, that means we are dividing half, right? So 1. So my range will be 0 comma 1. And my here range will be what? 2 comma 2. That means the single element. Till when we are going to do this? When we get this. We cannot divide further, right? We'll get each leaf node as a single element. Here range will be 3 comma 4. And here the range will be 5. Okay, now further we will we will divide it, because it is not single element. Here we'll get 0 and 1. Here we'll get 3 and 4. Okay, now it will be range 0, range as 1. Now here range 3, range 4. Okay, I mean I have written 0 1 because it is 0 to 0 and 1 to 1, 3 to 3, 4 to 4, like this. Okay, so now what we got, this is our segment tree. Now we have found range. Let's now write the index. Okay, I'll use some different color as blue. Okay, index. Initially, let's say this is an 0. Index is, this is index of what? Index of new array. We are going to represent it, right? Okay, or let's say before index, I will write the value. What is 0 to 0 range? This is my 1, 2, 3, 4, 5, 6. What is the index 0 value? Is 1. Okay, value is 1, and here value is 2. Here value is 4. At index 3, 0, 1, 2, 3, the value is 4. Here the value is 5. Here the value is 6, and here the value is 3. These are the leaf nodes. That means each element in an array. Now let's say okay, here this is an example. Instead of maximum value, we will be using the sum, and then when implementing we will use the maximum. Okay, now what we will do is, this is the sum. Okay, so 1 plus 2 is 3. Why 1 plus 2? Because right now our question is the sum. So from range 0 to 1, what is the sum? 1 plus 2. If I have asked from range 0 to 1, what is the maximum value? Maximum of this one and this 2 is 2. Now for this range 0 to 2, what will be the value? The sum is this 2. 3 plus 3 is 6. Now the sum of range 3 to 4 will be what? 4 plus 5 is 9. Okay. Now here the sum will be 9 plus 6 is 15. Now the sum of all the elements in the array will be 15 plus 6 is what? 21. Now, okay. Later we'll represent first. Let's see. From 0 to 2 means 0, 1, 2. What is the sum? 3 plus 2 is 5, 5 plus 1 is 6. You can say 6. Let's say this 3 to 4. Okay. 0, 1, 2, 3. 3 to 5 is 4 plus 5 is 9, 9 plus 6 is 15. So in this way we have found this range, sum of these ranges. Now the question is, how we will find the what? The sum of, let's say, 2 to 4. Query, this is what? Build. This is what? Build. Right now what we have seen. First we will find the range. We have this range and then these values. And okay, we'll have to store these values in the array. As I said, representation in array. So the indexes will be, let's say this is my I. Initially I is 0. Okay, this is my I. Then its child will be, formula is what? Left child will be 2 into I plus 1. Right child will be 2 into I plus 2. Why these formulas? Because at each level, see, there are two elements. Here first level it is 2, next level it is 4. In the next level, if I have these nodes also, okay, it will be 8. Like it will be 2 to the power 1, 2 to the power 2, 2 to the power, not 2 to the power, it will be multiplied of 2. So if my level is 1, that means 2 into I is, there are 2 elements. If my level is this, then means there are 4 elements, 2 into 2. If my level is 3, but there are, how many elements are 8? Okay, of course it is 2 to the power, not into. Okay, but why we are multiplying into? Because see, here it is 0, here it is 1, 2, because initially I is 0. But when I is 1, 2 plus 1 is 3, 2 plus 2 is 4. That means here 1 at each level. Okay, if I multiplied, why we are using 2 times? Because here if I multiplied by 2 is 4, 4 plus 1 is 5, and here it will be 6. So basically how we are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like that. Okay, so using left child we will find using this, right child using find this. Okay, now this will be I 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, in this way we will store this. Now the part is query. Okay, now we have built our segment tree. The part is query, and my question is query of 2 comma 4. In the range of 2 comma 4, I want the sum. Now how we will find? See, there will be what? There will be 3 conditions. What are these 3 conditions? Not conditions, you can say 3 things which we have to consider. One is this 2 to 4, if I have here, okay, then what? If I have all this in the same range, or uh, see, 2 to 4 is in the range, in the range, or out of out of the range, okay, or partial. Okay, these are the three things. That means I have this 2 to 4 in the range, or out of, let's say this 0 to 2 is there. For this it is a partial. 0 to 1 it is out of the range, and for 0 to 5 it will be in the range. Okay, so for this 2 to 4, what we will be doing as, see, this is the whole sum, okay, initially. But then if we go this side, because we want 2 to 4, exact 2 to 4, so we have this 2 this side, we have this 4 in this range, so we'll have to divide this. Okay, now if I divide this query 2 to 4 to, as we will be using the divide and conquer, as it is a partial, if partial is there, again we'll have to divide. Okay, now if we divide, what we'll get is, our question will be, what will be the this is, means, see, our part is, when we are querying, my I have 0 to 5, okay, in which my query is there, okay. But then here we'll have to go this side and this side. So instead of dividing this, what we are going to divide our range. So we will split the ranges. Okay, so I will go in this range, or I'll go in this range, okay, while querying. So my 2 to 4, my this is in this range, and also is in this range, okay. And in 3 to 5, I have partial range is 0 to 2, I will get here. Okay, wait, I'll use the color, then you'll understand. I'll use the marker. Yes. Now, for this query 2 to 4, my 2 is here. I'll go down. I'll get this range where I have my this 2. Now, for my other 3 to 4, where I'll go down here. I have 3 to 5, but I want 4. I'll go down here. What? I'll get this 3 to 4. Now I will do the addition. What I'll get is 12. So what is the answer from 2 to 4? 0, 1, 2, 2, 3, 4 is 9 plus 3 is 12. Yes, you can see. In this way, we will be finding this. So what I mean to say is, instead of divide and conquer, we will apply on the ranges. So we will find these ranges which include, like, using, right now, see, using this two range sums, we are able to find this. So similarly, if I have the query as, let's say, query as 1 to 4. Yes. Okay. I have query 1 to 4. Now let's use some different color. Yes. I have query 1 to 4. So in the range, out of the range, partial range, as I explained. Okay. So if my this query is in the range, okay, then I can say is, this 2 to 2 is in the range, 3 to 4 is in the range, so we have used this. Okay, now out of the range means we will be returning maximum and minimum value. If we are finding the maximum, else we'll return the 0. If for partial range, okay, because here and 4 1 and 4 is in different ranges, we don't have exactly 1 to 4 range. Okay, now I will go for 1, I'll go here, I'll go for 1 to 2, I'll go here, I got this 1 here. Now I got 2 this here. Now 1 to 4 is there. For 4 I went here, and then I got this here. I have 3 to 5, and then I got this sum here. So my total sum is 2 plus 3 plus 9. 9, 10, 11, 12, 13, 14. So total is 14. So 1 to 4, that means this is 14. So in this way we will be finding. So what we will do, we will shrink our range and find our sum, okay, value for this query. Okay, now here, wait, yes, let's now write the code. Here I explained using the sum example, but while writing the code, we can write for maximum and minimum value for better. Here you can, for sum it is very easy. Okay, and you will be asking why we used segmentary for sum. We can also use the prefix sum concept as well. That is also fine. Just for explanation, I explained segment tree. Okay, let's take class, and in this I'll take as I am going to store in the array. We will take int nums one array, initial array, and int n, which will be the size. I'll use the constructor to initialize. Is we will user will pass us the array. So this dot nums is equal to nums. Okay, and n is equal to nums dot length size. Now tree initially is equal to new int. We have to initialize. So in this segment tree, maximum 4 into n sized. Okay, n size elements we will get. And here why I'm using the 2D array, because I want to find the maximum and minimum value both. So first element will be my minimum value. First is minimum and second is max. Okay, now why 4 into n? So see, as I explained, so every level we will go down that many this we will get. Okay, multiplied by 2. Okay, but see here, not multiplied by 2, it will be okay, yes, okay, it is given that maximum we can have 4 into n. If you want the more detailed explanation on why this, because it has some derivation, so I can explain in another video. Here in this video it will get more. Okay, the length will be more. Now let's we what we will have to write first build, which will return a single array build. Okay, we have to build. So what I'll pass the index, I'll pass my L, and I'll pass my R. Okay, low and high. So while building, what we did is first we'll have to use the range. Okay, now if while building, what is our leaf node, what is our base condition is if my L is equal to R. In that case, we reach the leaf node. That means what we will write, tree of index of 0 will be what will be nums of index, nums of L, not index. And tree of index of 1, it will be nums of L. Both are same, right? This L and R. That means this L will be here. L is my range, these are the range. L is my 0. Okay, so nums of 0 is value 1, right? So we are going to set. So first we'll get the leaf nodes, and here we will return the tree of index. Okay, now if we see, if we first we will set all the leaf nodes, this this and this. Now we will return these values. Okay, now we'll get this value. So here we found the sum, instead of we will find the maximum or minimum value. Now first I'll find the left. If my base condition is not true, that means I am, let's say I am here. Okay, first I want left, then right, and then only I can find. So in left is equal to what I'll get, build of what, index. As I said, 2 into index plus 1 for left child, 2 into index plus 1, and here right for 2. Now we have to find the mid. Int mid is equal to L plus R minus L divided by 2. Okay, here L comma mid, we will go till mid. Now for int right, build of 2 into idx plus 2 for right child, and here from mid plus 1 to R. Why? Half, right? We are using the divide and conquer. So here from 0 to 1, here it is 0 1. For 0 to 2, the range we divided 0 1, and we found the mid. 0 plus 2 by 2 is 1, and then the mid is 1 here. Mid plus 1 is 2, 2 to 2. In this way we will find this ranges. Now we got left and right. Okay, now we receive these values. Now we will find the maximum and minimum. As I said, the first value will be minimum and second is maximum. We are going to find it. Now my tree of idx of 0, that is first is minimum, mat dot minimum of what, left of 0 comma right of 0 as the first element from both. Now I want to find the maximum, then mat dot max left of 1 right of 1. Okay, now we got, and then we will return this tree of idx. In this way we build our array. So here it is only 1, but here we are finding the sum. So initially the first value, as I said, it is minimum. That is why we are taking the first value of left, right, and second value for maximum. Okay. Now we will write the query, the main part. It will also the array return and query. Here what we want the index. Here we want the int low and int high. This will be our question query, and this int l comma int r. As we are going to shrink the range, so we are going to shrink this l and r. What are the conditions? If my low is less than or equal to l, and my high is greater than or equal to r, then it is in the range. Then we will return the tree of idx. Okay, my l and r is there, and my low and high is from here to here, so we will return this. Okay, now the second is out of range. So out of range, my low is greater than the r, or my high is less than the l, then it is out of range. My l is here, r is here, and my low is this side, or my high is this side, which is out of range. So we will return the max and min value. So first is the minimum value, so I'll return the integer dot max value, and here I'll return the minimum value. That means infinite, you can see. If it is not in the range, we don't have anything. If it was sum, then we would have written the 0, because here we are going to compare. Now see, here it will be same. Again, instead of build, we will use the query. From left we will find, from right we will find, then find the minimum, then find the maximum, and the return. Here now we'll have to find the mid also. Okay, and before that, here we'll have to pass the low and high also. We will not change our low and high. We are going to shrink the range. Okay, in this way we will find. So basically query again, for we will see on the left side, we will see on the right side. Okay, on the left side, if we are in the range, we will return this tree of idx. If it is not in the range, this. If it is partial, again we'll go down. So till when we get in the range. So you can see here we got 1 in our range. Yes, this 2 we got in our range. Here 3 to 4 is in our range. So basically we are checking if this range is in this. Okay, so here you can see 0 to 5 is not in this range. Okay, this is what? This is not even out of the range. This is partial. Okay, yes. Now let's see, let's run this main. I'll take int array is equal to, yes, we are going, let's see this example. First, what we'll do, segment tree is equal to new segment tree, and we'll pass this array segment tree dot build. First we'll build this, pass the 0. What is the size is 1 2 3 4 6 7 8 9, sorry, 7 is the size, 8 is the size, and the maximum our range is 7. It will build our tree. Now let's print this. Let's take int answer is equal to segment tree dot query initial plus index. My low will be, let's say I want from 2 to 7. What is the minimum and maximum value? And initially this will be n minus 1. So okay, and I'll print it. Okay, it is showing index out of bound LR 7 of 7. Wait, instead of that I'll write this. Oh yes, because the size is 7, how can I pass the 7 index? I'll have to pass 6. Yes, you can see 4 and 8. So from index 0 0 1 2, that means from the here to index 6, what is the minimum is 4 and maximum is 8. Let's say I want from this to this, that means I'll pass 3 and 5. S5 and 7. So in this way, the implementation of segment tree I implemented using Java. And for minimum and maximum value, you can make, where is the error somewhere? Okay, maybe I did something. Yeah. Okay, thank you so much for watching this video. If you have any doubts, please comment on this video. If you want any more conceptual videos, then please let me know in the comment section. Thank you so much for watching.